We have been very busy at MOT and have completed the culverts, installed the bridge, completed the pipelines and insulated them. You do see that the jetty is very high. We've installed these enormous loading arms and they have to be able to reach the top of the deck of the very largest carriers, which can be 35 meters high. In 12 meters water, that's about 25 meters above sea level, 350 meters long, enormous vessels coming into this facility, which can have 260,000 cubic meters of LNG, which has to be loaded within 1 day. But also smaller ships, they must be able to be reached by these loading arms, which can articulate downwards. What we see are the piles of 2.80 meter diameter, which have been driven some 35 meters into the seabed. 6 of these are to anchor the ships, called mooring dolphins, and 4 of them in front of the jetty are to absorb energy and are called the breasting dolphins. In extreme conditions, when we would have a northeast storm, the ship would come with quite a large speed against the fenders. Then the fender takes energy, but the pile itself can actually move 75 centimeters to the side without transferring any load to the bridge. There's a lot of monitoring of weather conditions, of wave riders, current sensors, which have to give their information. Together with the weather forecast, we can then decide on whether a ship should come in. Furthermore, we have monitoring systems which show how quickly the ships are approaching the shore so that the captains can make sure that the berthing energy is taken on slowly. When a ship arrives in front of the Rotterdam harbour, it is allowed to sail in at 2400 hours. It takes on board a harbour pilot. The harbour tugs are connected to the ship and they continue their journey around the protected island into the harbour and sails out again through the opening in front of the harbour. Recently, in March 2011, the dredging commenced to break through the channel to the sea. When that was completed, this protective island became a totally independent piece of land.
Following the 3 successful hydro tests, we tested the integrity of the entire structure and then we started with insulation. Insulation of the suspended deck is made out of 3 layers of mineral fiber blanket, which is very similar to the insulation that you will find in houses underneath a roof, for instance. Perlite is slightly different. It's a powder, white color, coming also from mineral. It is very light material, around 40 kilograms per cubic meter. Very high property of insulation. And between the inner tank and the outer tank, we have 8,000 cubic meters of perlite. We vibrate this perlite to increase the density because during the cool down of the inner tank, the steel contracts and generate a volume to be filled by the perlite. So we have a reserve at the top of the annular space, and this reserve, with the higher density due to the vibration, will fill this volume. The tank is very similar to a vacuum bottle, meaning that the heat exchange with the outside is limited, creating as less as possible boil of gas. The entire duration of the insulation works takes approximately 5 to 6 months per tank. We are now standing on the top platform of the tank. We can see behind me the yellow jib crane, which has been used for installing the low pressure pumps. We've got on this project 7 low pressure pumps, 3 on the first tank, 2 on tank 2 and tank 3. These low pressure pumps came from the United States under nitrogen package to avoid any moisture. These low pressure pumps have been lowered in this pipe called the pump columns, which are about 50 meters high. These pumps are the heart of the tank. If they don't work, the storage tank is of no use. So the low pressure pumps are submerged pumps, meaning that they sit all the time in LNG at minus 160 degrees. About 150 millimeters from the bottom of the tank on a foot valve. This foot valve has springs which can close. We do therefore several checks during installation to make sure that during maintenance phase, when we remove the pumps, the foot valve closes and we have no gas cloud coming out from the pump column. Such a pump could run for 30 years, but due to stop and start, we maintain the pumps on the 5 working years basis. Each and every 5 years, average time, the pump is taken out of the pump column and fully checked. Purging is made to decrease the oxygen content to less than 5% and to have a dew point, which means the moisture content of the tank, at a dew point of minus 40 degrees. The purging is made in 2 steps. The first step with dry air and the second step with nitrogen. We've closed the tank behind us. We've got the temporary nitrogen tank, which are being used for purging tank 3. Following the purging, we then come to the cool down of the tank. We've decided on this project to cool down the first tank with liquid nitrogen at a rate of 3 to 5 degrees per hour. And tank 2 and tank 3 will be cooled down with LNG. The purpose of using liquid nitrogen is to avoid to release to atmosphere gas, natural gas, which contribute to the global warming effect.